Hey guys, in this video I'm going to show you how to answer the Maths Method Sample Exam 2 Extended Response Question 5 Parts A to D. This question was testing your understanding on transformations. And so reading the question we've got let the function f where f of x is defined by the given rule and the function g where g of x is defined by the given rule. Express x to the power of 4 minus 8x in the form x times x minus a times x plus b squared plus c. To factorize x to the power of 4 minus 8x, we can use the factor command in the calculator. And so factorizing this, and so in factored form, x to the power of 4 minus 8x can be written as x times x minus 2 times x squared plus 2x plus 4. Now this is not in the form required. The quadratic factor needs to be written in turning point form. And to do this, we need to complete the square. And so using the complete the square command in the calculator, we can get this in the turning point form required. And so in the form required, this is going to be x times x minus 2 times x plus 1 squared plus 3. Part B. Describe the translation that maps the graph of y equals f of x onto the graph of y equals g of x. F of x in the factored form is equal to x minus 3 times x minus 1 times x squared plus 3. We just worked out g of x in factored form, and this was x times x minus 2 times x plus 1 squared plus 3. Looking at the x term in f of x, we can see that this has been changed to x plus 1 in g of x. And so therefore, we can say that g of x is going to equal f of x plus 1. F of x plus 1 in function notation means that we've translated the graph of f of x 1 unit to the left. Part C. Find the values of d such that the graph of y equals f of x plus d has one positive x-axis intercept. F of x plus d is going to translate the graph of f of x d units to the left. Looking at the rule of f of x, we can tell that it's going to have two x-intercepts. The first one when x is equal to 1, and the other one is going to be when x is equal to 3. And so the coordinates are going to be 1, 0, and then 3, 0. If we translate this graph d units to the left, then the new x-intercepts are going to have the coordinates 1 minus d 0 and 3 minus d 0. And so for the graph of y equals f of x plus d to have one positive x-intercept means that the first x-intercept must be less than or equal to 0. And so we can say that 1 minus d has to be less than or equal to 0. And for the second intercept, this has to be larger than 0. And so 3 minus d has to be larger than 0. And so solving for d has to be larger than or equal to 1, and d has to be less than 3. And so therefore, the values of d, where y equals f of x plus d, is going to have one positive x-intercept, is going to be when d is larger than or equal to 1, and when d is less than 3. Part 2. Two positive x-axis intercepts. For y equals f of x plus d to have two positive x-intercepts means that we want the first x-intercept to be larger than 0. If the first x-intercept is larger than 0, then the second one will also be larger than 0, which will result in two positive x-intercepts. And so we want 1 minus d to be larger than 0. Rearranging this, we're going to get d is less than 1. And so therefore, when the value of d is less than 1, we're going to get two positive x-intercepts. Part D. Find the value of n for which the equation g of x equals n has one solution. For g of x equals n to have one solution means that if we draw a horizontal line, y is equal to some value n, then this line can only intersect the graph of g of x once. If we have a look at the graph of g of x using the calculator, we can see that it has a minimum point. And so the only place where we can draw a horizontal line where it touches the graph of g of x only once is going to be a line that touches the minimum point. And so the value of n is going to be the y value of this point. To see this graphically, we can find the y coordinates of the minimum point. The y coordinate is minus 7.56, and so if we draw the line y is equal to minus 7.56, we can see that this line will only touch the graph of g of x once. And so for g of x equals n to have one solution, the value of n must equal minus 7.56. However, we need an exact value. And so all we need to do is work out the y coordinate of this minimum point. And to do this, we can use the fmin command. This is the x coordinate of the minimum point. To find the y coordinate, we need to evaluate this when x is equal to 2 to the power of 1 on 3. This is the y coordinate of the minimum point, and so therefore the value of n is going to equal minus 6 times 2 to the power of 1 on 3. And that's it for this video. Now if you guys want to learn or revise exam style questions related to transformations, then you can do this easily by logging into the Maths Methods Club, where you can group past exam questions related to this topic. Just click on functions and graphs from the main topics, and then click on transformations from the subtopics. And for extended response questions, go to question type and select extended response. Here you're going to see all the past exam questions related to transformations in the extended response section. Go through these questions so you're better prepared for your SACS and exams. And if you get stuck, just watch the video solutions. Thanks for watching, good luck, and I'll see you in the next video.